Hello, good morning. This is Naz from NB Network Lessons. A very good morning to everyone, all of my students. Thank you for joining. Today, my discussion is going to be continued discussion on sequences. I introduced you to what sequences are in advanced calculus in lesson 70. And we're going to solve some problems today and see, if that makes sense. So this problem, which I'm going to do right now, I'm almost certain that it's going to be on your test. So problem is, does this sequence converges? Okay, that's the question. And another part of that is that if it converges, and then let me know at what value does it converge. So here it is. The sequence is an is equal to 1 over 4n square. All right. And then we have basically limit is from 1 to infinity. Okay. So then what we do is that we say, okay, we have this problem an is equal to limit 1 over 4n square, all right, and then this limit is gone, n is approaching infinity, all right. So now, actually this is n approaching infinity. So now my question is, if I replace n by infinity, what does it become? It becomes 1 over infinity. And what is that? What is 1 over infinity? 1 over infinity is 0. Okay. So then, do we know if this particular sequence converges or it doesn't? It does converge. And it converges to 0. So this function is going to be like this. It starts from right here, okay? It goes down and then finally converges to 0 right here. So that's one of the questions most likely you're going to get on test is. So answer is yes. Answer is yes. It converges to 0. Okay. All right. So let's go ahead and move on to another question. So the next question is also an important question, and you might see that on your test because the next question I'm going to solve involves applying L'Hopital rule. And if you are hazy on L'Hopital rule, I have 3 or 4 lessons in my collections under calculus, and it's really interesting topic. So let's say question is an is equal to n square minus 1 over n plus 1. All right, and the limit is n is approaching infinity. So the way to tackle this is, what you do is you plug in the value of infinity, you replace n by infinity. When I do that, infinity square minus 1, that's going to be infinity. Infinity plus 1, that's going to be infinity. Okay. So then what do we have then? When we plug that in, what do we have? Infinity over infinity. So anytime when you get infinity over infinity, okay, you know that you have to apply L'Hopital's rule to find out the answer. So in L'Hopital rules, what we do is that we take derivative of numerator right here, and we take derivative of denominator. So let's go ahead and do that. So when I do that, I say limit n approaching infinity derivative of n square is 2n, and derivative of 1 is 0. So this is 2n over, I'm sorry, this is also n square. So then the derivative of n square is 2n, and derivative of this one is 0. Okay, so then I get 2n over 2n 1. So then I can say, after applying L'Hopital rules, we can say that the sequence converges at 1. All right. So that's all I wanted to discuss in this particular topic. Stick with me, and I'm going to come back with some more problems. One of the problem is, does this function converges or diverges? We're going to look into that. Stay tuned. Thank you so much for watching. If you like the contents, please go ahead and give me a like and share as much as you can. You know why? Because sharing is caring. Thank you.